The Roboball started in 2003. We had a kind of a nutty idea of this ball that could roll around, which we now call Roboball 1. And the vision for that was a mission to the moon. And I'd seen a bunch of pictures of these craters on the moon that were really interesting, that had potentially materials on them like water that would be really useful. But they were so big and so cold that I just knew we would never send a human down in there. So the idea was you'd roll a ball. I see a lot of applications, a number of roles that a ball can play. I think the opportunity on the moon is very real. I'm really lucky to have such wonderful grad students here, and across all the projects, the A&M grad students are awesome.
A lot of the work that I do on this project is more on the hardware side. So I work kind of in the role of like a design engineer, where I work on, maintaining the robot, designing its structure to make sure its performance is optimal, and then, performing upgrades as we learn things about how the robot wants to behave, how it performs, stuff like that. Goals that I have for Roboball are to see it be robust enough to tackle those missions without having a lot of operator input, and being able to meet the performance criteria that a robot requires to be able to tackle that kind of terrain.
I've always just been obsessed with the idea of seeing these balls just like zoom in. When I first started Roboball 3, it wasn't super fast, but now, like, through a lot of time and testing and simulation and trying different things, we've got it up to 20 miles per hour, and we're trying to always go faster. So that's always my goal, is to get these things to move faster, smoother, more controlled.
This team is a really inspiring team to be on. It's by far some of the smartest people that I've ever met, and rather than everyone kind of working on their own goal, their own theses, it's a team of people who are solely interested in watching the ball get better and watching it progress. And so seeing everyone work so hard towards this common goal and put in their time, their effort, their ideas, and support everyone else on the team and their contributions to the robot makes it really rewarding and inspiring to be on this team.
They really are great, and they really are smart and know what they're doing. And it's always fun, building robots, controlling robots, testing. And it's really rewarding to do it with your friends. Long term, I'm hoping by the time the Space Institute is finished building and it has those moonscapes and the Marscape, we can take the robots out there and simulate like a full mission, and kind of just, as much as you can without going to the moon, prove that these things do what we wanted them to do.
It's all about the students. And so I'm here to help those students grow and learn, and along the way develop some new ideas that they take out into the world with them.